Hey, seventh grade, we're going to start our study, or we have started our study actually, of the scientific method. And so the purpose of this lecture is to help acquaint you with the different steps. I'm going to divide it into shorter sections so you don't have a whole lot to watch and try to understand at one time. And then we will also be practicing each of these steps in the class. So my hope is in the end that you're able to apply the steps, the process of scientific method in order to solve problems on your own. Okay, so what is scientific method? We've talked about this already a little bit in class. It is a series of steps that scientists use to solve problems and answer questions, and they use common sense and logic to do it. It's not just a wild guess, not just a wild prediction. They actually have some information, some knowledge that supports their the way they solve the problem and answer the question. Okay, sometimes you're going to hear scientific method called the scientific inquiry or investigation. That's fine too. Pretty much the same thing. Okay, so other scientists, you and other scientists, actually use the scientific method every day to solve problems. You probably just don't realize that you're doing that. As anytime you use logic to solve a problem, it's very similar to what scientists do. Okay, so the first step in scientific method is making an observation. So when you're out and about in the natural world and you use your senses, whether it's your vision or your smell, or I don't know if tasting is really a smart idea, or your hearing or touch, like you measure a temperature, you say, oh, it's really cold in the classroom. Yeah, that's an observation, right? Okay, so we're going to talk about a specific situation in which scientists observed some really freaky frogs. We're going to call it the freaky frog experiment. And so they were at this pond where the frogs were reproducing, living, and growing, and they found a lot of frogs that looked in ways that they didn't expect. So they had a lot of different deformities. I will highlight, if you notice here, this frog doesn't have a hind leg here, and this one is missing one as well. So when they went to this pond and they were making observations, they saw these things. So they started doing some research, and one important thing to remember is that your background knowledge is very important. Okay, so in this case, one of the really important pieces of background knowledge that these scientists needed and that you would need in order to investigate this is the life cycle of a frog. So they start as eggs. An adult frog will lay eggs. They will then mature and grow into tadpoles, and then the tadpole will develop into a froglet that's still pretty much in water most of the time. So the egg and the tadpole stage, those happen in water, of course. The froglet, can maybe get out of the water, but still spends most of its time in water. And then the adult frog will live out of the water, but it needs the water in order to lay its eggs and reproduce again. Okay, so that's some important background knowledge. And if you think about it, the legs, let me show you here. So if you notice that eggs don't have legs yet, but the next stage, the tadpole, they do have these little, they're starting to have little eggs. So the scientists can make the assumption that that the deformity is happening somewhere between the egg and the tadpole stage, because that's when those legs are actually developing. That's when the frog body is starting to develop. So they can make a pretty good assumption. It's a pretty strong assumption to say that those deformities are happening between this stage and this stage. Okay. So once you've made all these observations and you're curious about, in this case, what in the world is causing these frogs to be born with the deformities, then you use your background knowledge, maybe about the life cycle of frogs that we just talked about, and other research to understand how frogs develop and what might affect them in such a negative way, what might cause them to have those really weird deformities, right? So your question, the next step in scientific method, asking or formulating a question, needs to be based on those observations, but also on the knowledge and the research that you've done and your curiosity. Okay, so these scientists, when they were researching not just the frog life cycle and about the growth and development of frogs, but they were also looking at the pond, the environment in which those eggs were developing. And they discovered there was some pollution in that water. So their question that they formulated was, could the pollution in the water possibly be causing those frog deformities? Okay, so they made observations, they did research, they collected information, they built their background knowledge, and then they've come up with this question. They think maybe, just maybe, the pollution in the water is what's causing the deformities. Okay, so the next thing that we need to talk about when scientists follow the scientific method is to formulate a hypothesis. But in order to formulate a hypothesis, you kind of have to think ahead about variables, okay? So variables are the different factors or different parts of an experiment, a situation, a test group that that we need to understand before we form a hypothesis, because when you write your hypothesis, you want to use these variables when you're writing. Okay, so the first variable that we talk about is the independent variable. Now, this is the factor that the scientist changes. And in an experiment, you can only have one independent variable. If you have more than one, remember, it gets confusing because you don't know. If you have multiple independent variables, if you have 3 or 4, when you look at your results, when you look at the number of deformed frogs, you don't know which one of those variables, which factor caused the deformities. So you have to narrow down your testing to one independent variable in a really good experiment. Okay, so in this case, the scientists decided to use differing amounts of pollution when the frog eggs were developing. So the independent variable in their experiment was exposure to different amounts of pollution. Okay, so remember that. That's our independent variable. The next variable that we need to talk about is the dependent variable. Now, the dependent variable is the factor that changes because of the independent variable. It's like the result or the outcome. So the independent variable, we're hoping, is the cause, and the effect is the dependent variable. So the scientists in this freaky frog experiment were trying to decide, right, if the pollution, the amount of pollution was what was causing the deformities. And so their independent variable was the different amounts of pollution exposure, and their dependent variable is going to be the number of deformed frogs. So they're going to actually count from their experiment. When the eggs develop into tadpoles and frogs, they're going to count the number of frogs that are actually born with a deformity. So that's the dependent variable. It changes because of the independent. It is affected by the independent variable. All right. The next variable that you need to remember are the control variables. Now, this is plural. If you notice, it has an S on the end rather than independent variable and dependent variable. So the control variables are any other factors that might have an impact, might cause some change in the outcome or the results for any of your test groups. So in this case, there are any factors that might also affect the growth and development of those frog eggs into frogs, okay? So they might possibly have something to do with those deformities. So in this case, we want to make sure that we control these and we keep these the same for every frog egg, no matter what amount of pollution it's exposed to, no matter what the change in the independent variable is, these, we got to keep them the same. Okay, so for example, we want to use the same type of frog eggs. We don't want to use a green tree frog egg in one group and, you know, some other kind of like poison dart frog egg in the other one. Okay, all right, so in this case, frog eggs, growth environment, amount of water temperature, and light exposure. Okay, and the length of exposure to the pollution. All right, I'm going to stop here and I'll do your next section, and we'll go on and talk about hypothesis.